Hello, my name is Daniel, and today we will be going through the AMC 10A from the year 2016. So let's get started. First problem, what is the value of this, right? And so we have 11 factorial and 10 factorial all over 9 factorial. What we know is that 11 factorial equals 11 times 10 times 9 factorial, and 10 factorial equals 10 times 9 factorial. So we can we can cross off 9 factorial from each, and so this will give us all over 1, and then these two get crossed out. So 11 times 10 minus 10. This is 110 minus 10, which equals 100. So the answer is B. Number 2, for what value x does 10 to the x power plus times 100 to the 2x power equal 1000 to the 5th power? Okay, so 100 to the 2x power is, so this is 10 to the x power times 10 squared to the 2x power, which is just 10 to the 4x power, right? This is 10 to the 3rd power times to the 5th power, right? So this is just 10 to the 15th power. And so this part equals 10 to the x plus 4x, so it's 5x power. This equals 10 to the 15th power. So 5x equals 15, x equals 3, right? The answer is C. Number 2, for every $1 Ben spent on bagels, David spent 25 cents less. Ben paid $12.50 more than David. How much did they spend in the bagel store together? Okay, so if Ben spent X dollars, then David spent X times 1 minus 0.25, so 0.75. So David spent 25 cents less, and since Ben paid $12.50 more than David, and 12.50 divided by 0.25, this equals, we can just take out the decimal sign because they're both at the second power, at the second place, decimal second place, and this is 50, right? And so Ben spent $50. So Ben spent $50, and so how much did they spend in the bagel store together? Ben spent $50 and David spent 50 times 50 times 0.75, so 3 over 4 equals 25 times 1.5 equals 25 plus 25 out of plus 25 times 0.5, which is 12.5. So we add 50, 25, and 12.5. So all these together equals 87.5. So the answer is C. Number 4, the remainder can be defined for all real numbers x and y with y is not 0 by this equation, where the floor of x and where the floor of x over y denotes the greatest integer less than or equal to x over y. This floor thing, this is used very much in AMC 10 as well as 12, and so you would do well to remember it. What is the value of remainder of this? So let's go just by the simple and easy method. Let's just plug this into here, and so that will give us 3 over 8 plus 2 over 5 times the floor of 3 over 8 over negative 2 over 5. And so this thing inside the floor, that will be 15 over 16. That will be 15 over 16, and the negative sign is still there. So negative 15 over 16, and the greatest integer less than or equal to negative 15 over 16 would be negative 1, right? And so we can just take this out and then make this a negative sign. And so 3 over 8 minus 2 over 5, this equals all over 40, and if we cross multiply, it's 15 minus 16, so it's minus 1 over 40, so the answer is B. Number 5, a rectangular box has integer side length in the ratio 1 to 3 to 4. Which of the following could be the volume of the box? Okay, so since 1 to 3 to 4 is the ratio, then that means we have something like this. We have a and 3a and 4a. So the volume would be a times 3a times 4a, which is 12a squared, no, 12a cubed. This could be something, and this is here, right? And so first of all, let's divide all of these by 12. And so 48 would yield 4. Let's do this in a different color. This would be 4. And 56 divided by 12 would not be an integer. 64 divided by 12 would not be also an integer. 96 divided by 12, that would be 8, right? And 144 divided by 12 is 12. And out of these numbers, what is a cubed value? So this is a cubed value, this is 2 cubed, right? And so the answer is D. Number 6, Ximena lists the whole numbers 1 through 31. Emilio copies Ximena's numbers, replacing each occurrence of the digit 2 by the digit 1. Ximena adds her numbers, and Emilio adds his numbers. How much larger is Ximena's sum than Emilio's? Okay, so what we need to find is how many 2's are in the numbers 1 through 30, right? And so for the ones digit, it's the ones in 1, 11, and 20. No, actually it's how many 2's, right? So it's 2, 12, and 22. And so we're looking at just the first digits, so we have 3 of them. And for the tens digit, we have everything from 20 all the way up to 29, right? And this time we are counting only the tens digit. So even in 22, we are only counting one of them. And besides, we counted the first digit. We counted the first digit already. So we get 10 values out of this, right? And so how much larger is Ximena's sum than Emilio's? Okay, so so we have 10 in the tens digit and 3 in the ones digit. So the difference would be 10 times 10 from right over here, and plus 3 times 1. 3 times 1. This equals 103. So the answer is D. Number 7. The mean, median, and mode of the 7 data values 60, 100, x, 40, 50, 200, and 90 are all equal to x. What's the value of x? Okay, so right now right away we can see that we don't need the median and mode of the 7 data values at all, because just the mean will give everything to us. So since the mean equals x, right? So 7x equals all these added together. So x plus 60, 100, 40, 50, 200 plus 90, right? And so we have 100, 300, 400, 490, and 540. So x plus 540. So if x goes over, 6x equals 540, x equals 90. So the answer is 90. It's D. Number 8. Trickster Rabbit agrees with Foolish Fox to double Fox's money every time Fox crosses the bridge by Rabbit's house, as long as Fox pays 40 coins in total to Rabbit after each crossing. The payment is made after the doubling. Fox is excited about his good fortune until he discovers that all his money is gone after crossing the bridge 3 times. How many coins did Fox have at the beginning? Right? Okay, so if we so there would be like a certain number of coins that Fox had at the beginning, and this is what we want to get, right? And so after he crossed the bridge 3 times, his money is 0. So since the payment is made after the doubling, there must be have a doubling and a payment and a doubling and a payment and a doubling and a payment minus 40, and it would have become 0, right? And so now what we do is we go in the reverse direction, right? So since something minus 40 is 0, then that would be 40. Since something times 2 is 40, this would be 20. 20 plus 40 is 60. 60 divided by 2 is 30. 30 minus 40, 30 plus 40 is 70. And 70 divided by 2 is 35. So that means Fox had 35 coins at the beginning. The answer is C. Number 9. A triangular array of 2016 coins has 1 coin in the first row, 2 coins in the second row, all the way to n coins in the nth row. What's the sum of the digits of n? Okay, so the sum of all the so the total number of coins. This is 1 plus 2 plus 3 plus all the way up to n, and we know the formula for this. This is n times n plus 1 all over 2, right? And so this equals 2016. N times n plus 1 equals 4032, right? And we know that since 2048 is 2 to the 2 to the e11th power by the game, and 4096 would be 2 to the 12th power, and that would be 2 to the 6th power times 2 to the 6th power, and this is actually pretty close to 4032, and this is 64 times 64, right? And 4032 is less than 4096, so let's say that n plus 1 equals 64, then n would be 63, right? So 63 times 64 equals 64 squared minus 64, which is 4096 minus 64, and this is actually equal to 4032. So it is confirmed that n is 63, right? And so what's the sum of the digits of n? It's 63, so 6 plus 3 equals 9. The answer is D. Number 10. A rug is made with 3 different colors as shown. The areas of the 3 differently colored regions form an arithmetic progression. The inner rectangle is 1 foot wide, and each of the 2 shaded regions is 1 foot wide on all 4 sides. What is the length and feet of the inner rectangle? Okay, so let's say that the length of the inner rectangle is A, right? And since both sides increase by 1, so the next would be A plus 2, and the last would be A plus 4, right? And since the areas form an arithmetic progression, so the areas of the white region, so this one here, that's A, and this middle region, that's A plus 2 times 3, because this is 3, and then minus A, and that gives us 2A plus 6, right? So 2A plus 6. And lastly, we have A plus 4 times this much is 5, and then minus A plus 2 times 3. So 3A minus 6. So this equals 5A minus 3, so it's 2A, and 20 minus 6, so it's 14. This equals 2A plus 14. Alright, so now what we have is the fact that 2A plus 6 and 2A plus 14, they make an arithmetic progression, right? And we know that the common difference is 14 minus 6, which is 8, and so this would also be 8. 8 plus 8 equals 2A plus 6, therefore A equals 8 minus 6, which is 2. So this is 2, the length and feet of the inner rectangle is B. The answer is B. Number 11, find the area of the shaded region. Okay, so as soon as you see this, you need to have the instinct to connect the diagonals, because that is the key to solving this entire problem, right? And so if we do that, then obviously we can see that this area, this green area, and this green area is the same, and this red area and this red area is the same, right? And so for the green area, we can see that this triangle, right, this triangle plus this triangle, they sum to half of the total area, right? And so it's half of it's half of that total area, and it's 1/8 of the total area, right? No, so it's 1/8 of so it's 1/8 of half the total area. So that would be, so green would be equal to 1/8 times half of the total area, And similar thing for the red. If there was something like this, right? So these two triangles, these two would also be 1/2 of the total area, and this would be 1/5 of it. So the red part equals 1/5 times half of the total area. And what we need is the total area. We see that this is 8 and this is 5. So the total area is 8 times 5 equals 40. So total area is 40. And so these both become 20. 1/2 times 40 becomes 20. Here too, it becomes 20. And so 1/8 times 20, that is 20/8, plus 20/5. This equals 5/2 plus 4, and this is 6.5. So the answer is 6.5. It's D. Number 12, three distinct integers are selected at random between 1 and 2016 inclusive. Which of the following is a correct statement of the probability P that the product of the three integers is odd, right? So for the product of the three integers to be odd, then all three has to be odd, right? And so to pick one odd, so to pick an odd integer from 2016, that's 1008 over 2016, and that multiplied by there's one gone from each, so 1007 over 2015, and there's also one more gone from each, and we have three, and we need three integers, so it's 1006 over 2014. And if you see these two cancel to make 2, these two cancel to make 2, and so this is 1 over 4 times 1006 over 2015, and we can see that this is close to 1/2, but 1/2 is equal to, if it's going to be over 2015, then it has to be 1007.5, and so this is less than 1/2, right? And so since we know that 1006 over 2015, this is less than 1/2, then 1 over 4 times that will also be less than 1/2 times 1 over 4. So this is the value that we want, and it's less than 1 over 8. So the answer is A. P is less than 1 over 8. Problem number 13. 5 friends sat in a movie theater in a row containing 5 seats, numbered 1 to 5 from left to right. The directions left and right are from the point of view of the people as they sit in the seats. During the movie, Ada went to the lobby to get some popcorn. When she came back, she found that B had moved 2 seats to the right, Ceci had moved 1 seat to the left, and and Eddie had switched seats, leaving an end seat for Ada. In which seat had Ada been sitting before she got up? So we have 5 seats. And first we see that since D and Eddie switched seats, they don't have like any kind of impact on Ada's seating, right? And so there are 2 possibilities for Ada to have an end seat, and that's for B to have been here and she moved 2 seats to the right, or Ceci was here and she moved 1 seat to the left, right? And so let's first consider the case that Ceci moved 1 seat to the left. And so if Ceci moved 1 seat to the left, this would be her new seat, and nobody should be here because this is for Ada, and B would have and B would have to move 2 seats to the right, and if B was here, that's not possible because this would and if B was here, that shouldn't be possible because this is Ada's seat, and if B is here, that shouldn't be possible because this is C's seat, and therefore that means that B can only be here, right? But then this means that this leftmost end seat, this is also being left for Ada, right? And so this seat is also being left, and so that means that B is going to come here, and D and Eddie switched seats, right? And so D and E are somewhere between here, but then that can't be possible because they have no space to switch seats, because both B and Ceci are in 2 of those 3 spots. So we conclude that this is not possible. And so this is the only way, and of course, as we saw before, Ceci can't come here. And so this is the seat that's left for Ada, and so so B would come here, right? And so Ceci would be here, and then she would be going over here to be here, and then this would, sorry, that should be a C, and these are the D and Eddie seats that they just switched over. And so this would be Ada's seat, and so in which seat had Ada been sitting before she got up? So that's the so that's the open seat in the front row, in the first arrangement. So this is Ada's seat, so seat 2. The answer is B. Number 14. How many ways are there to write 2016 as the sum of 2's and 3's ignoring order? Okay, so first let's kind of dissect 2016. What is 2016? If we divide this by 2, this is 2 times 1008. And if we divide this by 3, it's 2016 equals 3 times 672, right? And so we can kind of make a chart here. So as the sum of 2 and 3, right? And so obviously one choice would be to have 1008 twos and no threes. And since both have to be an integer, right, then the number of threes should increase by 2 and the number of twos should decrease by 3, right? And so 3 can be 2, and so that way 2, there will be 1005 twos, and so on until 672 threes are reached and there are no twos left, right? And so how many ways are there to do this? So we have we have this many ways, and so if we count in the number of terms in here, then that would be our answer. And so let's divide this by 2. This would be 0, 1, 2, all the way up to 336, right? And so this much is 376 numbers, so including 0, that's 337 numbers. The answer is C. Number 15. 7 cookies of radius 1 inch are cut from a circle of cookie dough as shown. Neighboring cookies are tangents, and all except the center cookie are tangent to the edge of the dough. The leftover scrap is reshaped to form another cookie of the same thickness. What is the radius in inches of the scrap cookie? Okay, so what we want is the area of these kind of in-between areas, right? And so to get that, what we need is we need to get the area of the full circle and subtract 7 of the small circle areas, right? And so first to do that, since the 7 cookies are radius 1 inch, this is 1 inch, and so this would be 3 inches, right? This is 1 and this is 3, and so the full circle is pi times 3 squared. This is 9 pi, and the 7 times 1 squared, and so 7 times 1 cookie, so 7 times the small cookie, equals 7 times 1 squared pi, which is pi. This is 7 pi, right? And so the area would be, so the area of the leftover, this would be 9 pi minus 7 pi, 9 pi minus 7 pi, which is 2 pi, right? And so the radius of the scrap cookie, let's say that's r, then that would be pi r squared. This would be equal to 2 pi, so r equals root 2. The answer is A. Number 16, a triangle with vertices. These points is reflected about the x-axis, and then the image is rotated counterclockwise about the origin by 90 degrees to produce triangle A2 prime, B2 prime, C2 prime. Which of the following transformations will return A2 prime, B2 prime, C2 prime to ABC? So let's draw the coordinate plane, like that, right? And then we will have 0, 2. We'll have this here, and this will be A. And negative 3, 2, that will be 1, 2, 3, and so this will be B, and C is negative 3, 0, so this is C, right? And so this is our first triangle, ABC, and then when it's reflected about the y-axis, right, then it's reflected about the x-axis, right? And so this will go like that. And so this is A prime, B prime, C prime, and then when it's rotated counterclockwise about the origin by 90 degrees, and so that will give us 2 and then negative 3, and so this will be A2 prime, B2 prime, C2 prime, right? And so what we have to do is we have to put this triangle back to this one, right? And so what we and so what we have to do is is like kind of flip it over to there, and what will be our axis? Our axis will be this, right? So we have to flip it over with our axis being this line, and this line is y equals x. So we have to reflect about the line y equals x. So the answer is D. Number 17, let n be the positive number. Let n be a positive multiple of 5. 1 red ball and n green balls are arranged in line in random order. Let Pn be the probability that at least 3 over 5 of the green balls are on the same side of the red ball. Observe that P5 equals 1 and that Pn approaches 4 over 5 as n grows large. Where's the sum of the digits of the least value of n such that Pn is less than 321 over 400? Okay, so n is a positive multiple of 5. So let's say n equals 5x, right? And so we have let's just say x equals 3, right? Then we will have 15 green balls. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 15 green balls, and we have 1 red ball somewhere here, and let Pn be the probability that at least 3 over 5 of the green balls are on the same side of the red ball. Okay, so for Pn to not be true, and so so for Pn to not be true, then this red ball has to go somewhere between these three, right? So it can go either here or it can go there, right? And as x increases, let's say x equals 4, then the range, then the possible area where the red ball can go is 3, right? And so if x is 4, then it's 3, and so we see that it's x minus 1, right? So the number of possible ways that the red ball could go, it's x minus 1, right? And this is the probability of not Pn, right? So this is not Pn, so at least 3 over 5 of the green balls, they are not on the same side of the red ball, and so this is for that to happen, right? And so this is all over how many slots can the red ball go into in total. So we have 15 and then plus 1, right? So that's 5x plus 1. So x minus 1 over 5x plus 1. This equals 1 minus Pn, right? 1 minus Pn. And Pn has to be less than 321 over 400. So negative Pn. So negative Pn would have to be greater than negative 321 over 400. And so 1 minus Pn would be greater than 1 minus 321 over 400. And this is equal to 79 over 400, right? And so 1 minus Pn equals 79 over 400, right? And so this is greater, so this is greater than 79 over 400. And so what that gives us is, so we have this, right? And so if we cross multiply 400x minus 400 equals 79 times 5, that is 395x plus 79. No, this is not equal sign. This is greater. So 5x equals 479, right? And so what is the sum of the least value of n? So 5x equals 479. No, actually, n is a positive multiple of 5, so x should be an integer, right? And so 5x is greater than 479. So the smallest x value is when 5x equals 480. So 480. So x equals 96, right? But then the question asks for the sum of the digits of the least value of n, right? So here n would be 480, and so the sum of the digits of 480 would be 4 plus 8 plus 0 equals 12. So the answer is A. Number 18. Each vertex of a cube is to be labeled with an integer 1 through 8, with each integer being used once, in such a way that the sum of the 4 numbers on the vertices of a face is the same for each face. And arrangements that can be obtained from each other through rotations of the cube are considered to be the same. How many different arrangements are possible? Okay, so let's draw a cube like that. And and we're going to separate this into 4 columns and 2 faces, right? And what this means is that the numbers on either side of these blue columns, those will be, so if there's integers 1, 2, 3, 4, 5, 6, 7, 8, then these will be the paired integers that always sum to 9, right? And so the pairs are 1, 8, 2, 7, 3, 6, and 4, 5, right? And so like if 1 is here, then 8 must be here at the other end of the blue column, right? And so if 2 is here, then 7 must be over here, like that, right? And so what we have to do now is we have to get what arrangements can we make for these red faces, right? Because we know the sum of the numbers on each face, right? And that is these sum to 9, so that is 18, face, and that is 18, right? And so we have to find one value from each of here that will sum to 18. And so we can see that that value is, what can it be? Yeah, 8, 2, 3, and 5 would work, because 2, 3, 5 is 10, and plus 8 is, that would be 18, right? And so one of these would be 2, 3, 5, 8, and then if that were to happen, then the bottom face would automatically be, since this is 2, this is 7, since this is, this is 7, since this is 3, then this would be 6, since this is 5, that would be 4, and since this is 8, then the bottom would be 1. And so this would be the cube, right? But then what we want is how many different arrangements are possible, right? And so we only have this one combination, and if you were to say, oh, there's 17642, then just look at this picture. We have both 2853 and 1746, right? And so 1746 is the same thing as 8235, so we just have one combination. So we have 2, 3, 5, 8, and then how many different arrangements are possible? That's just 3 factorial, because we are reordering to 3, 5, 8 like we are sitting in a round table, right? So it's 3 factorial, which is 6. The answer is C. Problem number 19. In rectangle ABCD, AB equals 6 and BC equals 3. Point E between B and C and point F between E and C are such that BE equals EF equals FC. Segments AE and AF intersect BD at P and Q respectively. The ratio BP to PQ to QD can be written as R to S to T, where the greatest common factor of R, S, and T is 1. What is R plus S plus T? So first, to put this in a diagram, we can do this. So so this is what we have. AB is 6, BC is 3, since BC is 3, AD will be 3, AD will be 3, and these will be 1 each, right? And the ratio BP to PQ to QD can be written as R to S to T. So this is R, S, and T. And what is R plus S plus T, right? And so what we can see is, first, APD triangle and triangle BPE. So BPE and APD, they are similar triangles, right? And the ratio of their length is 3 to 1. And so that means this to this. So R to S plus T. So if we have R and S and T, R to S plus T, this would equal 1 to 3. So that would equal 1 to 3. I'll just write it as S plus T in the middle of here. And same thing happens when we look at AQD and BQF. They are also similar, but this time their length ratio is 3 to 2. And so R plus S to T, that will be 2 to 3. So 2 to 3, right? And so this time it's R plus S to T. So I'll write 2 in the middle of R and S like this, and then T will be 3, right? And so R, S, and T, they are all fixed values, so their total sum has to be the same, right? And so this total sum has to be a multiple of 4, and the total sum also has to be a multiple of 5, right? And so if we do multiply by 5, and multiply by 5, and for 2 and 3, we have to do multiply by 4, right? And so this gives us that this is R and this is T, right? T is 3 times 4, so R is 5, and T is 12, and S is, R plus S is 8, so S is 3, and to check, S plus T is 15, and that is indeed true. So that is our RST values, and what is R plus S plus T? 5 plus 3 plus 12, this equals 20. So the answer is E. Problem number 20. For some particular value of n, when a plus b plus c plus d plus 1 to the nth power is expanded and the like terms are combined, the resulting expression contains exactly 1001 terms that include all 4 variables a, b, c, and d, each to some positive power. What is n? Okay, so first we have a plus b plus c plus d plus 1 to the nth power, right? But then but it must include 4 variables a, b, c, d to some positive power, right? And so we need at least a1, b1, c1, and d1, right? And so for a, b, c, d1, so for the powers of these to be from 0 to anything, right? Then we have to take away 4 from this value, because we need to guarantee at least 1 for each, and then divide the remaining n minus 4 between a, b, c, d, and e, right? And so this becomes n minus 4, right? And so now we can see that if the power of a is big A, and if the power of b is big B, and all the way to if the power of 1 is big E, then we can say that a plus b plus c plus d plus e, this equals n minus 4, right? And now we have to decide what values will go in A, B, C, D, and E, right? But then yes, so to do that, let's write a list of 1,000. Let's write a list of n minus 4 ones. So it will be 1 1 1 1 1 1 1 1 all the way to the n minus 4th one, right? So this is the total list. But yes, so and then now what we need to do is put lines between some of these ones to divide which one will serve as the boundaries between A and B, B and C, C and D, and D and E, right? Okay, so we need to put boundaries between A, B, C, D, and E. So we need to put four of these boundary lines, right? And so we have n minus 4 of them, and we need to add 4 of these boundary lines, right? Like this and like here. And so we need to add 4 boundary lines. This would give a total of n lines, right? And so our final equation would be that 1001, which is the number of terms. This would be equal to since there's n kind of n lines to choose from, so that's n times n minus 1, n minus 2, n minus 3, each for A, B, C, and D, right? And then since these are 4, so the numbers can be switched around, so it's out of 4 factorial. So 1001 times 4 factorial, which is 24. This is n minus 1, n minus 2, n minus 3, right? And we know that 1001 times 24, let's try to dissect this. 24 is 12 times 2, and 1001, that is that is 7 times 143, and then this is 11 times 13, right? And so if we put the 7 and 2 together, then we get this, this equals 11 times, this equals 14 because of 7 and 2, times 13 times 12 times 11 by this, right? And so now we can know that n minus 3 is 11, n minus 2 is 12, n minus 1 is 13, and n equals 14. So what is n? N is 14. It's B. Problem number 21. Circles with centers P, Q, and R having radii 1, 2, and 3 respectively lie on the same side of line L and are tangent to L at P prime, Q prime, and R prime respectively, with Q prime between P prime and R prime. The circle with center Q is externally tangent to each of the other 2 circles. What is the area of triangle PQR? Okay, so let's draw a diagram of this. So this would be the circles, and since they have radii 1, 2, and 3, this is, so this would be 1, this much would be 2, and this much would be 3, right? And they are lying on the same side of line L, and they are tangent to L at P prime, Q prime, and R prime respectively. And what is the area of triangle PQR? Okay, so we want to find the area of the triangle that is connected from P to Q, and from Q to R, like that, and from P to R. And and it's very tiny, but you can see that there is area here that exists, right? And so we want that area, and so what we can do is we can put lines like this, right, that are perpendicular to line L, and so those lines will be like this, and we'll go like this, and they will make this as 1 1 1 and 1 1, right? And so by that, what we can do is let's say this is A, this is B, and this is C, right? Then we can take the value of PQA, right? PQA, and add QRB, and add ABCQ, and then subtract PRC from it, right? And so that's what we're going to do. So what we have to do now is PQA. So APQ. This is this triangle right over here, and since this is 1 and this is 3, right? And so by the Pythagorean theorem, we have that this length is 2 root 2. All right, and so this is 2 root 2. So this is 1 times 2 root 2 times 1/2, which is root 2. And we have RB and QR, right? So this is 1 and this is 2 and 3, so the hypotenuse is 5. And so also by the Pythagorean theorem, this is root 24, which is 2 root 6, right? So that's 2 root 6. So BQ is 2 root 6, and QRB, that's this triangle over here. That is 1 times 2 root 6 times 1/2. This is root 6, right? And then AQBC, which is this rectangle over here. BC is also 1, right? So ACBQ, this is 2 root 6 times 1, which is just 2 root 6. And now we have to subtract PRC, right? And so we have to subtract PRC. It has height of 2. This is 2, right? So this is 2 times, and this is 2 root 2 plus 2 root 6. 2 root 2 plus 2 root 6, and that times 1/2 because it's a triangle. And so this will be equal to 2 root 2 plus 2 root 6, right? And so it's this plus this minus this. And so it's root 2 plus root 6 plus 2 root 6 minus 2 root 2 plus 2 root 6, right? And so these two cancel out, and that gives us root 6 minus root 2. That's all that's left. That's the answer. It is D. Problem number 22. For some positive integer n, the number 110 to the n cubed has 110 positive integer divisors, including 1 and the number 110 and n cubed. How many positive integer divisors does the number 81n to the 4th power have? Okay, so we know that 110, this is 2 times 5 times 10. No, 2 times 5 times 11, right? And so if it has 110 divisors, that it means that 110 n cubed equals something equals like a to the 1st power, b to the 4th power, and c to the 10th power, right? And 110, this is already 2 times 5 times 11 already, so a, b, c are 2, 5, or 11. And let's try to make the smallest possible value, and so this would be 11, and this would be 5, and this would be 2, right? And this would, no, actually 4 would be 5, and this would be 2, but actually whatever's in here, it doesn't really matter. And so this gives us that n cubed is 5 cubed and 2 to the 9th power. So n equals 5 to the 1st power and 2 to the 3rd power. And how many positive integer divisors does 81n to the 4th power have? So 81 is 3 to the 4th power, and this to the 4th power is 5 to the 4th power and 2 to the 12th power, right? And so this gives us 5 times 13, right? So this is 25 times 13, which is 325. So the answer is D. Problem number 23. A binary operation diamond has the properties that A diamond of B diamond C equals to A diamond B times C, and that A diamond A equals 1 for all non-zero real numbers A, B, and C. Here, this is multiplication. The solution to the equation, this can be written as P over Q, where P and Q are relatively prime positive integers. What is P plus Q? Okay, but then first, the fact that A diamond A equals 1, this should have kind of made you think, is this diamond actually the divided by sign, right? Because then this would obviously be true, right? So let's check if this is true, and if it is, then we can see that this is divided by sign for good. So A divided by B over C this is A divided by B, so it's A over B times C. So this equals A times C over B, right? So it is actually the same thing, and so we can just say, replace this diamond sign with the divided by sign, and so to calculate this, we have 2016 divided by 6 over x, right? This equals 100, and so 2016 times x over 6 equals 100, so x equals 600 over 2016, right? And this is, let's try to divide by 6, right? Then that will be 100 over 336, and this equals, let's divide this by 4 again, all over 25, and it would be 4 divided by, so 336 divided by 4, so that's 84, right? So it's 25 over 84, so 25 plus 84 equals 109, so the answer is A. Problem number 24. A quadrilateral is inscribed in a circle of radius 200 root 2. 3 of the sides of this quadrilateral have length 200. What is the length of the fourth side? So first, let's draw a diagram of this. It'll be something like this, right? And so this is our quadrilateral, and it's inscribed in this circle of radius 200 root 2, and 3 of these sides have length 200, so this, and this side would all have length 200. So let's write that, 200, this will be also 200, and this will be also 200, right? And what's the length of the fourth side? So we want this length, right? And it's inscribed in a circle of radius 200 root 2, so this is 200 root 2, this is 200 root 2, right? And since this is 200 root 2 also, no, actually, what we can see is that since these sides lengths are all equal, and also these lengths are all equal, that means all of these 3 triangles, they are all congruent, right? And so this angle is equal to this angle, and this, and also equal to this angle, right? And also if 180 minus the red angle was to be represented with 2 times the blue dots, so it will be like this, right? And so this plus 2 of these blue dots would equal 180, right? And so then this would also be then this would also be the blue dots because of this big triangle, and since this and this are equal angles, so this would also be a blue angle, right? And we don't really need this blue angle. No, we don't really need this blue angle. But then now we can see that the ratio of this triangle and this triangle is actually the same, right? And so this would also be a red angle, right? And also this triangle is similar to this triangle, right? And so if this length is A, let's say it's A, right? And then since this is 1 to root 2 to root 2, then that means this is root 2A, and this is root 2A, right? So 200 equals root 2A, A equals 100 root 2. And so A equals 100 root 2, and root 2A, this equals 200. So this is 200, and since this and this is symmetrical, that means that this length is also 200, right? And since this is 100 root 2, but the whole thing is 200 root 2, that means this thing is 100 root 2, right? And since this is also similar, that means this is 1 to root 2. That means this middle length is 100. And so what we wanted is the length of the fourth side, and that side is right here, right? But then we know this length and this length and this length, that is 200, 100, and 200. So the length is 200 plus 100 plus 200, which equals 500. So the answer is E. Our last problem, number 25. how many order triples x, y, z of positive integers satisfy the LCM of x, y equals 72, LCM of x, z equals 600, and LCM y, z equals 900. Okay, so here we have x, y, and z. We have x, y, and z, and LCM of x and y is 72, and 72, this equals 8 times 9, so it's 2 cubed and 3 squared. X, z is 600, this is 2 cubed and 3 and 5 squared. And 900, this is 2 squared and 3 squared and 5 squared, right? And so x and y both have 2 cubed, 3 squared. No, actually, it's the least common multiple, right? And so first let's try and search for what x has. And so since x and y and x and z, they both have 2 cubed, but y and z don't have 2 cubed, that means x definitely has 2 cubed. And by the same reasoning, x, y, so the ones with y have 3 squared, the ones with y have 3 squared, but the ones without y doesn't have 3 squared, so that means y definitely has 3 squared. Same thing, the ones with z definitely has 5 squared, but then the ones without z doesn't have 5 squared. That means z definitely has 5 squared, right? But then we have these leftovers, right? Like this one, or this one, that don't perfectly fit in like that, right? And so for these ones, I'll mark the x, z, the 3 from the x, z in red, and this one in blue, right? And so in x, z, right, there must be 1, 3 somewhere around here. So there are 3 possibilities. X can have 1, 3, and z can have none, or x can have a 3 and z can also have a 3, or x can have none and z can have a 3. So these are the 3 ways, right? But then for 2 squared, it's a little bit more complicated, and it's between y and z. They have at least 2 squared, right? So at least one of y or z has to have 2 squared. So if y has 2 squared, z can have nothing, or y can have 2 squared and z can have 2, or y can have 2 squared and z can have 2 squared, or z can have the 2 squared and y can have 2, or z can have 2 squared and y can have 1, right? So these are 5 possible ways, and what we have to do in the end is actually very simple. Just multiply 3 ways times 5 ways, because this and this, they both happen at the same time, so it's multiplication. So 3 times 5 equals 15. The answer is A. And so that was it for the 2016 AMC 10A, and thank you for watching.